Also, it's a kind of a lazy day. So, what we were doing last week was changing the objective function, and there was one tableau that I didn't do. So, pivoting from this tableau, you were supposed to get this. If you've done it, you can check whether you got the same values as I did. Anyone? This time no one did anything. Yes, you did? Yeah. Did I get it right? Yes. Okay, now, thank you. If you did, you get a mark. There might be some chocolate for the marks. So, okay. And we kind of started this thing that I called ranges or something like that in the previous lecture, in last week's lecture, I think. And the idea of this is usually to decide how much you can. So sometimes you're interested. I mean, we're doing kind of cool examples, but sometimes you're interested in a practical application in knowing how much you can change these values for the solution not to change to a different basis or something like that. Because changing a different basis might mean starting a new production mix. You have lots of products to choose from. Some of them you're not making, some of them you are making. So you want to know what changes in the prices of the products you're selling, or the prices of the things you're buying, or in some resources and things like that. How much they can change without you having to pivot or change the basis or change the solution dramatically. Okay, so that's the exercises for this week, and we've not really done a lot of it yet. The exercise that you got asks you for how much the right-hand side of the second constraint can change, and how much the -5 here can change. So that's the exercise, but we're going to have a look at all the other values. Okay, so these is next. So the first question is how much can B1, which currently is 15, so that's the right-hand side of the constraint 1. How much can it change for the current basis to remain optimal? Okay, so right. So that's a straightforward question, I guess. And what we're really asking is, what happens if this right-hand side is 15? I'm not going to just make this into a 15. 15 plus some difference delta. Okay. So if I add delta to it, so delta can be negative, means I'm changing it from its current value of 15 to something kind of near 15. And we know what's going to happen, don't we? So we know that the val is going to change. Okay, so well, we studied things like this before, where we studied when it changes to something fixed. And we know that if just the right-hand side changes. The only thing that changes is the val, the right-hand side column. So it's not going to be anything else that changes in the Tableau. So the new val, how much does it change by? Or what does it change to? Does anyone remember? Well, maybe not. But then the right-hand side, they go with the slack variables. Okay, so the constraints, each of the constraints goes with one slack variable, so each of the constraints has one column. We're doing something with the first constraint, there's the S1, and yeah, what we want to, what we're going to get is delta times this column is added to that column. So what we're getting is 3 plus delta. This stays 7. 7 plus delta, and 34 plus 2 delta is in the objective row. This is obj. This is x2, s2, x1. Okay, in this Tableau, what could go wrong?
If your delta is more than negative, less than -3, then you'd have -5.
Yeah, well, that's more specific than I was expecting. Yes, you're right, of course. But what could go wrong is that some of these values in the top 3 entries could become negative, right? And then we would have to do a dual pivot. So the basis remains feasible if all these values are 7 and 7 plus delta are greater than or equal to 0. Okay. And if we have all these conditions, then the basis is feasible, and then we don't have to pivot at all, and the same basis remains the optimal basis. So this means that delta has to be greater than or equal to -3. This doesn't mean anything for delta, because that's always true. And this means that delta has to be greater than or equal to -7. So we've got these two conditions, and they both have to be satisfied, and they're satisfied exactly when delta is at least -3. So So the basis remains optimal. For delta greater than or equal to -3. And if we are interested in the right-hand side as well, then this B1 has to be at least 12. Okay, because it's 15, because 15 plus delta, 15 plus, and the delta is at least -3, and something one's at least 12. So, so pretty much as an exercise, we want to do the same thing for B2, what do we get? Oh no, I don't want B2. B2 is the homework problem. I want B3, don't I? Sorry. Let's do B3 instead. Have you got it yet? So if B3 is 4 plus delta. See, it was 4 in the original problem. What do we get?
It's the new ones.
Hmm?
The new ones.
The new ones, yeah. What are they?
3 take 3 delta.
Yeah, that's right.
7 plus delta. 7 take 2 delta. 34. So
Okay. So there's not much to do. So again, we want 3 minus 3 delta to be at least 0, and 7 plus delta to be at least 0, and 7 minus 2 delta. It's boring. So this is have you got it yet? What's the first condition for delta then? Less than or equal to 1. And greater than or equal to minus 7. And less than or equal to oh, that's right. So what does that give me? It gives me delta between minus 7 and 1. Which means that B3 is, well, what was B3 again? B3 is 4 plus delta, so B3 is between minus 3 and 5. That's kind of the answer. So in some books, this is called the allowable range for B3. Well, I need to do this slowly because we've basically covered everything we wanted to cover this term. There's not much else to do. Okay, is that clear? Are there any questions at all? So that's the question, what happens, or how much can we change the amount of resources available, or something like that, because that is changing the right-hand sides. But we have a similar question we can have for changing the objective function coefficients. Okay, so perhaps the third question would be, how can C1, which is currently 7, okay, what changes if we change C1 is not 7, but it's 7 plus delta? What changes in the tableau? Is the val going to change? Oh, maybe not. Not much of it in there. Is anything in the matrix going to change in the inverse matrix? No. Is anything over here going to change? No. So the only thing that is going to change is the objective row. Last one bit was too big. How much is it going to change, or what is it going to change to? No idea. Okay. How do you get 34? Just knowing the tableau, how would you get 34 for the objective? Just knowing the optimal solution is 7 and 3 and 0. You do 7 and 3 and 0, you get 49, 15, 34. So what you're really doing is seven times this number minus 5 times this number, 0 times this number, because x1 is the less coefficient, so minus 5, x2, 0, it's not in the objective. But that's actually true for much of the tableau. The only place where it's not true is here, because there you need to subtract the original value. So here you would be doing 7 times 1 minus 7. Here you're doing minus 5 times 1 plus 5. And here you're doing 4 again, minus 5. So you get 5, but you have to subtract the 1 from here. And that plus you get 4. But that's not, doesn't really matter too much. It really just changes by, so in this case, because we're changing C1, we're changing what we're timesing the last row by. Okay? Instead of 7, we're timesing it by 7 plus delta. So instead of what we got is we're going to get delta times this, more or less. So, in other words, this is going to be 34 plus 7 delta. This x1 thing, that just stays 0 because, well, yeah, it stays 0. Firstly, because it's in the basis, so it has to be 0. But because, yeah, okay, so we're adding delta times 1. But then, remember, we had to subtract the original value, and that's again subtracting the delta back, so nothing changes there. And we're adding delta times 0 here, so nothing changes there. For x3, there's a 0 there, so 4 doesn't change at all. Here we get 2 plus delta, 0, 1 minus 2 delta. Again, if we want the current basis to still be optimal, then we want to avoid any negative numbers. So we have 2 plus delta greater than or equal to 0 and 1 minus 2 delta. Greater than or equal to 0. So this is delta greater than or equal to minus 2, and this is delta less than 2.5, I guess. So the allowable range for C1 is what? Well, delta has to be at least minus 2. C1 is 7 plus delta, so this is 5. And the top is 1/2, so 7.5. 15 over 2. It's not equal, but is. So if we keep changing the 7 anywhere between 5 and 7.5, the same basis will be optimal. And if we go beyond that, we'll have to pivot. And kind of the last question that we can ask is, what if C3 changes? And that's the easiest of them all. So currently it's 1. If it changes by delta, then the objective row is going to look like this. What's it going to look like? Well, C3 is not in the basis. It doesn't, not anywhere here. So we're not using any multiple of any of these rows. So the only place where C3 has an influence is in the X3 column, right? Because that's where we're taking away one from the one in the objective. So what's going to happen is we get 34, 0, 0 here, and 2, 0, 1, just like before. And here we get 4 minus delta. So we want 4 minus delta greater than or equal to 0, which means delta less than or equal to 4. So the allowable range for, what are we doing? C3 is, well, there's no lower bound on it, and the upper bound is 4 plus 1, so that's fine. Fairly straightforward. So again, as I said last week, there is a difference between when you're changing the cost coefficient or the objective coefficient of a basic variable, where you have to do a bit more work, as opposed to a non-basic variable where there's very little work to do. Any questions? Something printed, which I don't know. So we kind of have some meaning for these entries over here. Well, remember that this is the dual solution. Yeah. Does that ring a bell? If you want some kind of economic interpretation, they're called the shadow prices. So what does that tell us? It tells us that if I change this 15 by 1 unit, the optimal objective is going to change by 2. So if the kind of resources, these 3 constraints, for example, boxwood and hours in a lake or something, in the test set problem, then every hour of or every extra unit of the resource gives me 2 more profit. Also, and the third one, why is there a 0 here? Does that make any sense? If I start increasing this 3, not getting any extra profit, why is that? Obvious. There's already slack on the second constraint, so if I'm increasing the amount of resource available, it's just going to increase the slack. It's not going to make me produce any more of anything. So assuming the basis means its dual optimal variable is 0, and its slack probably non-zero most of the time. They're kind of the value of the resource or something like that, if you want. And these are called reduced costs. Can you stop that, please, at the back? It starts to be annoying. Thank you. So these reduced costs, well, we only have one non-zero one, and that tells us how much the objective value, the objective coefficient of that variable has to change for that variable to enter the basis. Again, if there are some kind of production quantities of something, the moment X3 is not in the basis, so not producing any of the third product, say. But if its profit per unit increased by at least 4, then it would make sense to start producing any of the third products. We've just seen in the that the range. Right, any questions? Right. Because we've basically covered everything, I thought we could do the next lecture in a sort of a tutorial way with some exercises. We've done a lot of these things, but perhaps you've not had a chance to try many questions like this. So we can have some questions that are basically like exam questions on this part of the course. Yeah, so if there are no other suggestions, I would just bring some exercises and then we can try and solve them in part together, in part individually. And that's the plan for next week. That's a bit early, but I've run out of stuff to tell you, so yeah, that's it for this week.